Hello everybody and welcome back to ASAP Physics. In this series we're going to be covering chemistry. To start with, let's look into what an ionic bond is. We have a periodic table, and the first thing you need to figure out is whether it's an ionic bond or a covalent bond. In this video we're going to be focusing on ionic bonding. So now how do we figure out whether this combination of NaCl is an ionic bond? Well, there's one huge property that follows with an ionic bond. In an ionic bond, the bonding happens between a metal and a non-metal. So as you can see here, Na is a metal right here in the first group, while Cl, which is chlorine, is in the seventh group back here. So Na is clearly in the metal section, while chlorine is clearly in the non-metal section. So, we know that NaCl is an ionic bond. But now, we have to be careful here. This itself, NaCl, is not an ionic bond. Well, in this case it is, but let's first figure out how to write the formula for an ionic bond. So let's erase this. So we know it's an ionic bond. That's the first step we need to do when using this. The difference between a non-metal and a metal. If it's between a non-metal and a metal, then it's an ionic bond. On the other hand, if it's between two non-metals, that's a covalent bond, and we'll cover that in the following video. So, we have NaCl, and the A should be lowercase. Yeah, but we have NaCl. So now, with NaCl, we need to write the ionic formula. So this is how we're going to do it. So let's first look at the charge for sodium. The charge on sodium is +1. And if you're figuring out how to use or how to find the charge, well, for metals, you count from 1 to 3. So for example, let's see, titanium. Titanium will have a +2. So anything in the turquoise section will have a +2 charge. That's something you need to know, unless special scenarios such as iron 2 or etc. For group 2 over here, the charge for all of group 2 is +2. The charge for all of group 1 is +1. So now let's go to the non-metal side. In the non-metal side, noble gases have a complete set, so that's good. So over here, at group 7, that's where -1. These guys basically accept an electron from the metal. Therefore, because you're adding an electron, you're going to get a -1 charge. And really quickly, let's talk about the fundamentals of an ionic bond. So what's happening in an ionic bond is basically a metal and a non-metal come together and they're trying to reach the stable octet. Now, how does this happen? Well, during the stable octet process, or during an ionic bonding process, the metal would give an electron, or will share an electron, or it's a complete transfer, not a share. It will give a complete transfer of an electron to the non-metal. When it does a complete transfer, then the metal is going to lose that electron, so it's going to gain a charge, while a non-metal is going to accept that electron, therefore making it a negative charge. Well, depending on how much the electron gives is what we look at this periodic table for. So for example, in group 2, all the metals would give away 2 electrons. Well, then which would it pair with then? Well, it would pair with something like any other non-metal that would need 2 electrons in order to make a stable octet. So let's do an example here. So we're back to NaCl. So with NaCl, how are we going to make the ionic formula? So what is the charge for Na? That's +1. What is the charge for Cl? That's -1. So the formula here is you bring this charge here and you bring this charge here. Now disregard the signs. Whatever number is that is going to be the number there for the formula. That's going to be subscript. So let's do it really quickly, another example. So because this one was pretty simple as it was 1-1. So let's really quickly do something between lithium oxide. Let's do lithium oxide. So for lithium oxide, really quickly, let's look at the naming conventions here, right? So anytime in an ionic bond, you would always use the "ide" for the nonmetals. That's how you would use the naming convention for ionic bonds. And now let's look at the formula here. So we know lithium is a +1 charge because it's losing that electron. Oxygen is going to be a -2 charge. That is important because it's giving away. It's going to accept 2 electrons from the lithium. So lithium Now we bring that 2 down from the oxygen charge. We disregard the symbol, and oxygen, now we bring that lithium charge down, which is just 1, and disregard the symbol. So the formula for this one is just Li2O. That is lithium oxide. And this is how you would use, or this is how you would write a formula for ionic bonding. And the naming convention, always remember to add "ide." And yeah, that really covers up most of it for ionic bonding. And one clear point is that it's a transfer of electrons between a metal and a nonmetal. Thank you for listening to this video on ionic bonding. See the following video for covalent bonds. Thank you.